So, hello there. Thanks for watching. You're watching the CNC Garage live stream on Twitch, on Facebook, or YouTube, or Mixer, or Periscope. I guess that's all of them. Yeah, I think so. Anyway, feel free to say anything in the chat while I work. This stream is about making cool stuff, and today I'm going to continue my work on a spherical bookshelf made of birch plywood. So my first attempt of making this shelf kind of messed itself up. So this is some parts of the shelf. It's supposed to be like 1/4 of a sphere, but I accidentally used the exact dimension of the birch plywood when I drew it in the CAD program, and I didn't take into account the tolerance needed to get the slots properly into each other. So to assemble it was too much of a pain, actually. So I really need to just go from 12 millimeters to 12.3 millimeters thickness, and that will probably help a lot with assembling it. And also I will make a bigger shelf at the same time, because this one was actually a little bit too small. So yeah, follow my process. I will go through the process from start again. I will first go through the CAD drawing in Fusion 360 from Autodesk. Then I will go into drawing it, working on that design inside a plugin called Slicer from Autodesk. And then I will go back into Fusion 360 again with a DXF file, a 2D drawing, and then make that into a CAM file for being processed by a CNC machine. And not everybody knows what a CNC machine is, so I can just talk quickly about what that is. Let me see if I can grab a picture. Oh no, it's too dark in the garage right now. But a CNC machine is a computer controlled mill that is able to carve out stuff of, for example, wood, plastic, aluminium, or other soft materials, and you can make stuff, and you can make sure the computer actually do all the heavy lifting or carving, so you get it precise and exact to your drawings. If you are a carpenter or a furniture producer or something, you might be able to have the craftsmanship to do this manually, but to be able to have a robotic CNC machine to do the work for you gets you the exact same results every time. And the best thing about it is that it's precise, it's fast, and you have your hands free to do other stuff while it's working. So most of the work with the CNC machine is actually setting it up, doing the drawing, making the CAM tool path for the machine, getting the material loaded onto the machine, clamped properly down to the machine so it don't move while you actually mill it, and then start the process. And when everything is perfectly in tune and you have done everything right in the all the preparing process, the actual making of for example, a furniture like a bookshelf will actually go pretty fast. And you can make more than one, you can make 100, you can make 1,000. It's just a matter of the amount of material, tools, and time you have on hand to make them. So to go from a prototype product of an idea, for example, this is a small bookshelf, exactly the same process. To go from an idea to a physical product can take just a matter of hours, just like in 3D printing. It's you know, 3D printing is a process where you add layers of plastic above each other until it becomes a product like this. This is actually 3D printed and it's a lot of drones up in here, but this is 3D printed, so it's layer by layer, positive adding process with just adding plastic. When you make stuff with a CNC machine, you have your material already, and you just remove the amount of material that's not needed, and you get the rest that you need to make the stuff. So it's similar, but not in the same way. It's a negative process, but 3D printing is a positive process. So yeah, and you can. I also have a 3D printer, and it's, let's see if it's online. It's dark in there now. So that's my 3D printer. Yeah, but let's do that another time, because now we're going to start the CAM process. Sorry, the CAD process, the technical drawing process, and then go from there. And hopefully in a few hours we will be actually milling this on the CNC machine. All right. So I will share my desktop. So let's try and do this. I really want to make a bookshelf that has a diameter of, hang on, so I'll just do this sphere, come on, great, sphere, there you go, front, yes. So I want this diameter to be quite big. I want this to be 1.5 meter. So that is 550 centimeters. So right now it's just a ball, but I want this to be, let's see. Now I'm going to cut this ball with a square. So I want a 25 centimeter diameter bookshelf. So I'll just do an extrude. Come on. Oh, I need to finish this form first. Just go from front. Yes, sure. Let's create this. Let's just extrude this. 25 centimeters thickness, and that's the reason why I choose that is that the normal book is just about 20 centimeters thick. So this is actually 25 centimeters. This is how 25 centimeters looks like on a plywood. So when you get this on the wall, it should look pretty alright, I guess. Let's try it out. So 25 centimeters, and we are not supposed to cut this, we are just making a new body, and we will move this. So let's move this forward until it just covers the front of our sphere. Like, yeah, like that. We'll just add a little 501, a little bit more. The next thing we'll do, we are going to use something called Combine. It's a tool inside Fusion that lets you take one body. These are two. This is called a body. So this is one element, and this is another. And you can use one of the elements to cut the other. So I want the sphere to be cut with this blue one, and then I want to intersect it, yes, and I want to make a new component. So I'll keep the tools and select, and then I'm left with this. So right now this is my entire shelf, I guess. I wonder if I can do anything with that shape now. Probably not. So I'll then send this into another plugin for Fusion called Slicer. I'll select it. come on, select, okay. Then the program will open, and the next thing I'll do is just wait a little bit until it kind of loads properly. I will use the original size in millimeters, and the original size in millimeters is so 1.2 meters right now. I want this to be a little wider actually, so I will do a scale inside this slicer. So I will use let's see if we have the right, oh we don't, so hang on, let's see how we solve this. So I will do a slice from the right side, no, a scale from the right side, so that will be, I guess that will be the length. Let's see what happens if we change this parameter. So if we make it 2 meters instead, 2000 millimeters, and it will take some time to scale, and now the bookshelf will be much bigger. Interesting. Let's see how this turns out. Let's make it a little higher as well. Let's make it 1500 millimeters high. Something like that. This will be interesting. Hopefully it will not take up too much material when it's being carved out. So then I will switch into something called interlocked slices. The next thing I need to do is set up my material type, and I will define this here. So my material size is 240. 240. Yeah, that's right. 240. It's actually 244, but just keep one. So and 1 it's 1 2 actually, and the thickness should be increased to 12.25, I guess. So, and I will carve this out with a 4mm end mill. That looks good. So right now this will take approximately 3 sheets of plywood to be milled out, and that's too much. So the cost of this shelf will be a little overkill, I guess. You also need to assemble it, and it's so let's decrease the amount of slices, the vertical slices and the horizontal slices. So let's go down. We actually need to fit a book inside of one of these, and we don't need that many slices the other way. Now you can see that the amount of sheets, oh that's too much, but it's kind of starting to look like something. So the question now is this good enough? Should I move these on the end closer to the center? You can move this wherever you want actually. Let's hope we can undo that. Let's see, count. Yeah, we can undo that. So that's a little too. So this is just a matter of taste and design, right? So right now this will be almost 2 meters wide, this shelf, and it will fit 1, 2, 3, 4. The bottom ones will actually not fit that much. They are just there to look cool, I guess. So the maximum depth of this shelf is 25 centimeters. So I'm just trying to work out what looks best now. So that's 5. Nina?
Ja?
Sjekk her. So, just needed to get some response from the wife on this design. So this is close to what we want, I guess. It looks cool. It's 2 meters wide and 1.5 meters high. So it's definitely a big shelf. It will take around 1.5 sheet of plywood. So an assembly needs to be done in the proper way. Alright, so let's send this into a DXF file in millimeter and export this to back into my computer. So let's call this sphere V2 2 meter bookshelf, 4 millimeter end mill, and 12/25 millimeter stock material. So the next thing is to import that design. Just need to save this one as well into the proper folder. So let's call this sphere bookshelf 2 meter sphere for slicer. Yeah. So, and the next thing will be to make a new project. Maybe we can speed this. No, let's just do it from scratch. So, just need to close my door. So, and we will need to make a sketch front sketch, yes. And we will need to define our stock material, and that's 240. I wonder why that happens all the time. 240, so 120 times. I really need to find out why I can't type this manual anymore. It's getting quite annoying actually. Let's just do it later on then. 244 centimeters. Let's do for 242. Actually, let's do 245 centimeters. And we will need our other dimension to be 120 centimeters. So that's our stock material, right? So this will be 12 millimeters thick plus an additional, how much should we put in there? There's no reason for doing too much. Let's doing 12.25 then. So let's do a new component of this, and let's call this stock material. Just stock, it's alright. And onto that stock we want to import our DXF file, yes, on that surface. Let's find our DXF file, and it's inside our vlog. Wrong folder, I guess. So why isn't it there? I'm pretty sure I saved it there. CNC Garage Vlog CAD. Oh, it's .zip. Why did it zip it down? Alright, so let's just unpack it then. Extract here. Let's go for it. So, and then we'll find our file, 2 meter bookshelf. Oh, it's 2 sheets of plywood, that's why. So now it's importing the DXF file. This will take a little time. So if you just joined, feel free to ask any questions in the chat. I'm making a bookshelf today. It's version 2 of my bookshelf. So we will not need our numbering. Well, maybe we'll just keep them. They don't bother us. The frame bothers us, but the annotation is okay, and the boundaries we need. Yeah, let's just do that. So now Fusion will try to import. Let's just make another stock. Yeah, that's the best thing to do, I guess. So let's just duplicate or copy, paste, stock 2, yeah. Let's just hide number 1 and then go into our stock number 2, hide our sketches, well, at least that sketch. And then on our stock number 2, this one, we will import a new DXF, and that will be the second sheet of material. So we will remove that frame. Yeah, and this is what we need. So we can now extrude this into our bottom. Let's make new components of them, and they will be the exact dimension. Yes. So now inside of this stock we will have more components, And all of those are these. Actually, we want these to be separate. But for now, let's just keep them like it is. So let's call them second sheet of components. Yeah, we can make sub folders into this. So let's create components. We can just select all of these and go like that, and we can actually do numbering as well, and that's pretty nice. So if we hide this and we look at, so where is our sketch? There it is. So let's call this, is that one? Let's call this what it's supposed to be called, Y2. Let's call this Y5. The reason for doing this is when you try to assemble these things, you really want to assemble them in the correct order, and if you kind of mess up your system, you have no idea which part goes into what, and it's just difficult when it's not Lego. If you don't know where the components go, nobody will ever know. So set 1. So these are all of my components. Now I can hide my. So, and I will do the same for the first stock of material. Come on. So there, this is my first stock. These bodies. So why is this hidden? There. So now they're correct. So this is the stock 1. Let's do the same for this. Call this stock 2. Oh, these are actually connected now. Well, it doesn't matter. All right. So so where are the rest second sheets? Where's my rest first? So these are my second, and where are the first? So they're the first time. Okay, so let's just try and do this. Let's do the same for all of these. They also need to be extruded into the material thickness, so we'll just use the stock setup for making those. We will make new components of all of those, and that will be called component 7. We'll just call that first sheet of components, and we will try to do the numbering on this. So let's just do the same. Let's make separate components from all of these, and then just rename them. So this one is supposed to be called, let's see, Y3, and this one is set. What is that? Set 3. Yeah, all right, set 3. So set is horizontal and Y is vertical, I think. Set 2. That one is Y1. All right, Y1. Set 4. And this one is this one is only labeled 3. No, that's the slot. Oh, there it is. Set 5. All right. Set 5. And now we can start to plan how we want to carve this out in a sheet of plywood to make the most of our sheet of plywood, because material costs money and we want to be as effective as possible. So when we use a square, we want to use all of the material inside of that square or that stock to carve out our furniture to keep costs down. So you can keep doing this for hours, but it's almost like a game of Tetris, because you really need to place as many as possible of your components inside of a sheet of plywood. So this, I'll just fool around with this until I'm happy, or at least satisfied enough. So this needs to go out over here. Oh, I'm not allowed to do that actually. I'll just leave it. It's okay. Then I'll just move the other one. So this is stock 1. I didn't see that one coming. So now I have a lot of components. I can actually break this out of... Yeah, let's just leave them in place for now. It's easy to hide them. I will just turn off my sketches, because now the only thing I need to focus on right now is to get as many of these on the same sheet as possible. So I'll just move these, or maybe yeah, let's move them away for now. Captured position, yes. Then I can go back. Then I have a history point, so I can just go blip. Oh, but it didn't go back then. So it's buggy. Interesting. That's nice to know, so I don't screw anything up. But okay, let's move all of these over here. Capture position again, and then why can I still see them? Is this a sketch that is visible, or is it something else? I haven't seen that one before. So what are all of these? So they're probably sketches, but sketches are hidden. So why do I see them? Sketches hidden, sketches hidden. Must have missed something. All right. Let's see how many we can fit in here. Maybe I should take the small ones out first. So that's this one. Move. Get out of the way. Oh, something looks buggy here. Just to undo this and find out why it looks like I'm not actually moving the components. Never seen this bug before. So I'm inside the main component, yes, so I will be able to see all of them. And inside my main component, I really want all of these to be cut, paste into my main component. Am I allowed to do that? Paste, 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 no paste. Oh. Maybe I should just kept them as bodies. So let's go back then. Maybe it's actually easier to do all of this inside one component. So I have my stock. It's actually just faster to do it one more time. So let's just do it one more time. Okay. Where they come? Let's don't keep the frame, but we want to see our sketch. Yes, there it is. Come on. There we go. And we want to extrude all of these to separate bodies. Let's just keep them as bodies this time, not do a component. Apparently that fucks things up a little bit. So new bodies, yes. And now let's rename them. So this is called set 4. And this is set 2. This one is called Y3. This one is called set 3. And this one is, I have no idea, Y1. Alright. So this one is called set 5. So if you just joined the stream, I'm making a spherical type of bookshelf of plywood today. Not that unsimilar to this one. So this is a small one with the same type of plywood, 12mm plywood. Yeah, it will interlock without using any bolts or nuts or screws, or glue for that sake. So it's pretty cool, and it's 2 meters wide almost. So set 5, yes, let's hide these bodies for now. Also let's hide that sketch because we're finished with it. And then we will need our second. So we will do it one more time. Insert the XF, and then we will need our second sheet of plywood. And there it is. It's on its way to be imported. We'll turn off the frame. Keep the annotation so we can rename it. And I guess it's time to save this. So we will call this for 2 meter plywood bookshelf 12/_25mm stock material 4mm end mill. And the reason why I write the type of material and end mill into the file name is so I don't have to look it up afterwards, because after a week or 2 or maybe a year after that you will not be able to remember what you programmed. Oh shit, I did a huge mistake. I forgot to turn off on dog bones inside my slicer sketch. I thought that was on by default, but it apparently wasn't, so I need to change this and go back. This sucks, but still, this is how the bookshelf is supposed to look like when it's finished. And the only thing I forgot was to turn on something called dog bone. It's always something, but it's better to see it now than when I start to mill this stuff, because then it's gonna make a mess. So this is how it will assemble. And let's just save this file, because I will need to use this as a user manual when I assemble its sphere 2-meter bookshelf slicer. Oh, then we have to do all of this all over. It's actually just easier to start from scratch. All right, that's how it is. So create sketch, and then type in our dimensions. D for dimension, select, yes, do 240 like that, and 120 centimeters. So this is our stock material, and it's supposed to be extruded to minus 12.25 millimeter. Yes. So this is our sheet of plywood, and just for the fun of it, let's just give it a proper finish so it kind of looks like wood of some sort. Alright, so this is our sheet of plywood. And then we insert our DXF file, and that is probably zipped down, so we have to unzip it. Just make sure. Let's call this V2. So let's find the file and unzip that, export here, we go. And then we have the V2 sheet number 1, import. Let's turn off the frame, we don't need that. So we need to extrude all of these into a solid body with the thickness of our material. So we will just use the underside of the stock component for doing that. And then it types in 25 millimeters automatically. Oh, we missed one. So no problem, we can just double click our extrude, and I'll just move my camera so you can see what I'm doing. So I'll just do that. So now we need to rename all of these files again before we continue, so we keep up on what type. So Y1, so this one is set 3. So, and this one is set 5. So this one is Y3. This one is set 2. And this one is set 4. Good. Now we can hide all of these. And then we can hide the sketch, and then we can do it all over with the second sheet of plywood. So, and that is that file. We'll wait for the DXF to load. It takes a little bit. I guess those files are pretty heavy to upload to the cloud. So, and extrude to the bottom side of our plywood. Let's make new bodies. Yes, go for it. Let's just rename those bodies into what they are supposed to be named, and that is Y2, Y2, Y4, y5, and the last one is z1. So I'll just double check something. I'll just start my Discord channel. So if you want to join the Discord channel, you can just use the invite in the Twitch chat, or you can use, I think I have a text overlay somewhere. No, I don't. Oh, sorry. If you join the CNC Garage page, then you will be able to say hello, share links, share your projects, and yeah, just join the community of makers. I would love to make an interview with other makers on Twitch, so you can show off your work area, what the project you have done, and we can have an interview and talk about it. That would be awesome. It's really fun to see what other people are doing with the creativeness and making stuff. So Y2, Z1, yeah, everything looks good now. So now it's just a matter of course, saving the project first. Sphere V2 M2 meter bookshelf, 12.25 millimeter stock, 4 millimeter end mill. So let's hide our sketches, we don't need them anymore. Let's also start, I can actually use our, oh, we can't, sorry. Yes, we can. We can use that as an indication of keeping inside the frame. That chat was not supposed to go to Twitch, so let's just try and show all of the parts. All of these small parts are very nice to fit inside the big ones. So this one, Y1, and this one, Z5. I'll just move them away for now. Oh, hello. Rotate back, come on. Yeah, just let's keep them over there for now. And then the other ones, small ones. This one is quite small. Well, it looks like a meter, but I guess it's right. So move, come on, move it. Let's move it over here. And then this one is small. Let's move that one away. And let's just place the big ones out first. So these are almost identical in size. This one is bigger, and these two are the same, and this one is even bigger, looks like. So now we need to move these two away, I guess. Let's just keep the big ones first, place the biggest problems first, and then work out the rest. So let's just keep them over here. Let's reintroduce our stock material. So if we flip these two, or at least one of them, around, like that, 180 degrees, and then we move it just up to the other one again. Then we might be able to use that space for something. So let's just keep it just tight, and then go 223, then go 5 millimeters to the side, because our bit is 4 millimeters and it will need at least 5. Well, let's say if we do it 4.1, then it should be, as long as the material doesn't start to move while we're milling it, we should be good. But let's just keep some space between. So if we do, the bit is 4 millimeters in diameters. If you have it for 5 millimeters on the side, then it will leave like a millimeter when it does one side, and then it will leave 1 millimeter on the other side. So let's do 8. I really want to keep a little clearance there so they don't crash into each other if they come loose. So, and the next one, this is nice and tight to the stock side. Let's see how if we can just squeeze it a little more closer. I'll just have to keep that in mind when I actually carve it out, that I don't crash into any of the clamps on the CNC machine. So that one, 10 millimeter, that's on the line. So if I go 5 back now, minus 5, no, sorry, 5, no, plus 5. So that will leave, that will take away any of the ugly sides of that stock material, because it's always been being manhandled when it's in shipping. So yeah, maybe I'll just leave it like that. And this one is probably better to flip around. So this, which one is that? Y3, I guess. Yeah. Let's just rotate that 180 degrees. And let's see, now it's bigger. All right. So what if we put that in center for now and just put it, how many millimeters is that? 715, 723. So it's like all under 10 millimeter. So it should do the same here then. Let's just go 10 millimeters to the side. Yeah. So if I place my other two big ones, they will probably need to go on another sheet anyway, but let's try it. So let's take this one, put it over here, maybe, it's close, 570, yeah, that's all right, something like that. And the other one is not able to go in there now, but let's do the smaller ones. So move, come on. Oh, didn't move the right one there. So redo. So that is called Y1. So this is tiny little one. I was hoping to get that inside there somehow. Maybe if we flip it the other way, or we put it, oh, it's better the other way. Or maybe we can do something like that. No. But this is actually hopefully good enough. So that's touching, and then this is not touching. Oh, this is close. I really have to check this in the simulation if it's actually too close. But let's try it for now. So, and let's do this one, set 5. This one can be rotated, I guess. It's too long for that, but that one is shorter, so that one can go over there. And this one will, yeah. Let's rotate. The reason why I'm doing this is to minimize the cost of material and of course the amount of trash you generate for the environment, because whatever material you don't use, you have to kind of get rid of it afterwards, and there's no much use for small pieces of plywood for anything, so you just have to throw it away, and that sucks. But so let's just let's use all of that. I usually save pieces of plywood that are bigger than maybe 20 by 20 centimeters. I usually save them for other projects, but small pieces like 5 centimeters and just they're basically trash. I have no room for, or no interest in working on that small size. Oh, this is so close. Damn it. No, it's too big on the other. If I flip it, it's still too big. No. Alright. So this one will probably, this one will probably have to go on another sheet of plywood. But at least I have minimized the other pieces to probably fit inside this sheet, at least that small one. And hopefully, probably too big, but so let's try the big one first. So that's set 1. Oh, it's so close. Oh, how much do I miss? I'm missing. Maybe if I flip it a little bit. Oh, it's so close. I can probably try to scooch that in there somehow. Just have to make sure they don't touch. So that's touching, and that is probably okay, hopefully, and that's okay over there. And we can probably scooch that one further up or down and move the other two. Yeah, let's just see how that simulation goes before we move it anymore. So let's do this other small one. So this is just a game of Tetris, basically. It's just trying to manage the best use of material. And sometimes you are left with like these spaces. And imagining you're already running the entire machine, so it's very easy to just put in some more designs into all of these holes in the or not used stock material. Unfortunately, you never have those designs ready when you need to, unfortunately. What I really want to do now is try to minimize so let's see. Yeah, I just want to minimize the amount of use space on that. That is a quite large piece of plywood I can use for something else another time, probably, hopefully. So I'll just try to keep everything as tight as possible without making it too tight. We want some structure in this piece of plywood when we're milling, so it doesn't fall apart while we're in the middle of the process. And this one, this is really close, but it's much better than the original. So let's go back and watch how the slicer suggested we should use these 2 sheets of plywood. It suggested that 1, 2, 3, 4 of the pieces should go on the other sheet, and now we have minimized it to only 1, and that's pretty good. And if you're better than me on Tetris, you might even be able to fit in the last one, but it looks hard though. Maybe if let's just play around with it a little bit and see if we can do something different. So if we had rotated that something like that, it will still need it's too close, and it's even worse on the other side. And if we switch places with another piece, will that help? No. What if we have so that would have fit there? No, it wouldn't. It looks hard. But sometimes, you know, sometimes if you just play around with stuff long enough, sometimes you find solutions that you were not able to see when you started out. So, and this is a matter of not making more trash than possible, and at least also cutting down costs on making stuff. So 1 sheet of plywood is approximately 50 euros. So imagining having to use 2 sheets instead of 1, that doubles the cost. You still have a half of sheet of plywood left, but that's kind of decreasing your possibilities to use it for another project. It's too close. Yeah, let's just leave it there. See if no, we're still stuck. Even if I move the other one, it would be the exact same problem. So let's just call it what it is. So just for fun, let's put a color to this, just so we are able to see what's what easy. Yeah, and when we are about to mill this out on the CNC, it will probably look like something like, well, not that colors anyway, but just to get an idea of how the parts will lay out on the... That in render didn't work. So, okay, we laid out most of our parts now, and the last part will have to go on another sheet of plywood. Actually, I think I have a sheet of plywood left that might be able to fit this one. So what I'll do, I'll just put this one down there for now, or maybe over here. Oh, here's better. I'll just drag this to the bottom. So the first thing we'll do is carve out these. So now it's time to go from a CAD point of view, like the design point of view, and back to a CAM sorry, not back to a cam, further on to a cam, and this is a cam inside of Fusion. We need to make a setup, and the setup defines how our CNC machine is set up with our stock material. So I'll just do this quickly. So we have defined a solid. Where is our solid? There it is. This is our solid. Alright, let's use that. Hi Reese, nice to see you. Just come back from university, turn on Switch, and you're online. Why so early? Well, I had a day off, so I'll just continuing on my bookshelf project, making version 2, bigger and better. This one is huge. This one is 2 meters side in diameters or something similar. And hopefully I will get the dimensions better this time. Or I would just throw away another sheet of plywood. But that's how we learn, right? So, and then I need to set my stock offset point, and it's down there. Come on. Hello. Wake up. Stock box point. Oh. So apparently I'm not allowed to model origin. Alright, that's right. It's the same point, so that's okay. I hope. I really like using a selected point for that. It's the same, so it's okay. So now I no, that's not the same. It actually rotated everything. No, it's okay. So it was just a field of view that messed it up. Okay, let's continue. Let's make a 2D contour today. Well, we're going to use our favorite end mill, the one that broke off in another stream. I think there's actually a material weakness inside a batch of those end mills I have. Unfortunately, that's the only 4mm I have with a straight flute, so I will have to continue using them and just keep an eye on them in case they break. Actually, I've broken off 3 times before as well, so just have to take it easy. So I need my samples, 4mm metric bronze aluminum. Yeah, that's right. Let's So, and let's just define these feeds and speeds already. We kind of tested this out the other night, and I was really happy with the feeds and speed I got from this. So where will you hang this shelf? In a living room or where? Well, yes, I will hang it in a living room. That's absolutely correct. We have 2 living rooms, and one of them has like a 5-meter long wall that's only used for a picture right now. So a 2-meter shelf will fit perfectly. Damn it! I switched to a condenser microphone. Another motherphone today. That I normally just use it for vocal recordings, but I was kind of tired of having my wireless microphone on me all the time. So I just wanted to try it out. So 2500 ramp, yes. I think we'll just keep this at 1000. And apparently it looks like it's a bug inside it that doesn't allow it to go faster than 30. But let's see. 2 flutes, yes, we have 2 flutes, and it's millimeters, and the length is actually longer. So let's go 16, 17, and 18. There we go. So it's as good as the previous one for me. Alright. So the microphones, the funny thing is this microphone costs like, well, it costs a little bit more because it has a wireless transmitter. But the microphone itself costs, you can just cable this with a mini jack into your computer, and that costs like 10 euros. And this microphone is much more expensive. So this is like 300-400 euros or something. And if they sound the same, that's very nice. I guess. So I'll just need to set up some stuff here. I'm considering using tabs on the small parts this time to make sure they don't fly up, like we did see on when the accident happened. So if you missed that accident, you can actually see it still on Twitch if you go to the clips. But it's probably gonna run out on time anytime soon. So where is that? That's this one, I guess. So if you go into this clip and you just go all the way until it's so this is where the accident happened.
A little over halfway into that milling process. It's currently milling.
So it's 2:53, 2 hours and 53 minutes in. Look at this.
Oh shit! That's gonna make a mess.
Look at that sparks flying, and I actually didn't see those sparks, but because my head was somewhere else at that moment, I was trying to find the mouse for the other computer to actually pause the Carve. So if you are awesome, please do try and make a clip of that on Twitch so it gets saved, because I don't know how to do that, and it looks like I'm not allowed to either. Looks like some viewers have to do it. So 2 hours and was it 53 minutes in? Yeah, 2 hours 53 minutes in.
Want to check out how the CNC machine
it was just pure luck that I actually
a little over halfway into
that milling process. It's currently milling birch plywood, Norwegian birch plywood, and look at this. Oh, that's gonna make a mess. Let's hope it doesn't fly away. And you can hear me. I didn't notice that it actually broke off. I could just hear the noise. You know, there's a high pitched noise when the bit touches the bit is the end mill, right? So this end mill of some. So this is another dimension though. But when this end mill hits material, it kind of makes a high frequency noise going of some kind, and that the noise kind of changes. But when the noise goes away, you know, there's something really wrong, because then it goes from to nothing, and then you know that it's not doing any job anymore. And that's how I kind of noticed something was wrong. And then the other guys on the chat went, "Oh, I saw sparks flying." So please do make a clip of that if you can. Yeah, let's go back. So tabs. I don't. Well, I'm considering tabs on these small ones, but it makes it harder to remove, fix all the material later on, because you really have to sand down the edges on those tabs manually later on, and manual labor sucks. So hang on, stock bottom, I think -1, then it should be 13.2. That's too much, so let's do 0. So it already has 25, so let's do 0.80. Yeah, 85. So the total depth should be 13.1. That takes into account if the material sometimes goes not laying flat, and that kind of fixes some of that. But the problem is that it carves straight down into the sacrificial board that you have underneath instead. So you want to kind of save your board, the sacrificial layer, but still you have to. It's much better to carve through the above material than not to carve directly through it, because that makes a lot of extra work. Then you have to do the whole process again. You have to calibrate the machine, and yeah, it suddenly takes over double the time to make this stuff. So it's much better to just slice through a little more than necessary, as long as your bit is long enough. So I'll just double check that before I start the CNC. So, and we'll do no more than 4mm each time, because that will make a mess. And the last piece, that should go from 11 to 13. Now let's do 3mm in the last pass, so we don't cut through before we need to. Alright, so you made a clip, but can't paste it here. But I think all clips will, if it's a Twitch clip, you can probably see what you're writing, and I can't, so Twitch TV. But if you made a clip within Twitch, it should just pop out inside clip here. Twitch TV. Oh, sorry, double audio. No clip was made in this time period. Alright. Yeah, no, the links get hidden for other people. So, but you can use, if you go to videos and editing or clip. Clip is probably Norwegian. But inside Twitch, there's videos, and there are probably something called this. I've never used this before. Maybe I can do this myself. I have no idea. Yeah, somebody made that.
Norwegian birch plywood and oh shit, that's gonna make a mess.
Nice, thanks. Looks like it worked. Awesome. Save this as a highlight. Sure.
Norwegian birch plywood and
let's do it. Yeah, I have no idea what I'm doing. Let's just, yes, cool, awesome. Failures are definitely an option. I love it. Perfect, thanks. Yeah, it works. Yeah. So let's go back. It's nice to save those fuck ups. All right, so 4mm each time, 3mm is the last pass, and use even step down, so you probably do more to make it solve the math. Order by islands, yeah, that's better. And we will not leave any stock. We will just go straight through, and we will preserve rapid speed. Yeah, rapid retract, safe distance 2 mm. Oh, that's close. Let's do it 3. Stay down level should be no more than 20. Lift height. We don't need that. So the question is, should we use ramp? Ramp is very good when you, that doesn't, yeah, let's use ramp. And let's use a 20-degree ramp. Oh, not a 200. And then we need to select something. So now we need to select the bottom side of our, let's do all of the small pieces first. So the structural integrity of our stock material. So you imagining there is a piece of plywood on my CNC machine, and that is clamped down with the normal clamps. I'm probably not going to use vacuum this time, so it will only be held down by physical force, right? At probably 4 points of each side of the piece of plywood. Imagine if I cut out all the big pieces of plywood first inside this picture. Then that will physically not strengthen it, will weaken the entire piece of plywood, and at some point that piece of plywood will just break off and the clamps at each side will not hold it down anymore. And imagine what happens then. That's going to make a huge amount of mess. So we really want to take that into account when we start carving an entire piece of any material, that we make sure we have enough physical strength to be able to do the whole thing without it breaking apart. So we'll just do these small ones first, and then imagining all of this rest will just keep in place. It will not break off. And then when we're finished with those small ones, and then we go on to the bigger ones, and we're just probably gonna do the middle ones first, but because there are no clamps there, and there are still some strengths left to, yeah, let's just gonna think a little about that. So this first part with this, the first selections I did, they will take the blue lines. They will take around 16 minutes to carve out. All right, and the next ones, let's just duplicate this. And then the new ones are there, yeah. And then we need to deselect what we selected on that first run. So 4 of those, and the rest needs to be selected. So what should we do first? These ones are the closest to the clamps on the sides. The clamps will be around where I have my mouse now. There, and there. There are no clamps on the top or bottom horizontal sides. They're only on the vertical, the y-axis sides. So then I need to take into account that if I do both of these, then there will be no physical line left to kind of keep things in place, just only here. But if I take one of them, so if I take this, and then this, and then I'm now almost finished with one side. So let's do those two, and then let's duplicate that one more time. So just had some side talk there. So those two, and then we will have to do at least that one, and probably that one, and let's do this one in the end. let's see how that turns out. There's only so much you can do when you do plan these things. Maybe I should turn on the vacuum table to keep suck down the material into the, just to be sure. It uses a lot of power, so I'm kind of trying to get away from using the vacuum because it uses like 6 kilowatts of power when it's on, and it keeps on for an hour, and that's like, so if it's like that's like €1 just in power for that hour or something. I don't know. So these ones and these ones and that one, and that the last one generates a problem actually. So what's the problem? Open passes are linked with both ways zigzag ramp. What the? So open passes are linked with both. What kind of error is that? Jesus. So let's just run the simulation. Let's turn on the stock body, turn off toolpaths, and we'll just see the flute this time on our tool. We'll hide everything inside, and then we do push play, I guess. So let's have a quick look at how this will carve out on the CNC machine. So it's starting with the center one, goes all the way through, all the way through, and all the way through. And let's pause it for a little second. So now we can see that you still have a lot of material in, so this piece of plywood will not break off yet, because it's not, you haven't made a straight line through the entire material, so it weakens. Now you have kind of done that, because there's nothing left there, and that might be a problem actually. It's better to take the right one first and the left one after that, because that's closer to the clamps. Yeah, but it's no errors. You can see the line here. There should be some red dots if there's problems on the way and during the simulation. So, but this one I need to fix. So it needs to do that one first. Maybe I should do both of the center ones before I do that one. Yeah, let's do that. Alright, back to the drawing board. So instead of doing that one, let's turn on this again and hide this. So instead of doing this one, I only want to do this one and this one. Now we wait for the calculations to finish, and this is where it's nice to have a recently spec'd computer. I'm running an Intel i9 CPU, has 17900 or something, with 64 gigs of RAM, and I have a Titan X video card, and that helps a lot with the calculations, because when these processes are running, they need a lot of CPU threads, and I have like 20 of them or something. And it uses a lot of memory as well, so it kind of helps when you're doing multiple passes to have multiple threads CPUs. So this one's and that one, yeah, let's just leave that one. So we're only going to do this one. Come on, calculate. Finished. Yeah, awesome. And at the end we need to do both of these. So we need to select one more. Need to select this as well. Have you got SSD? Yes, I have an M2 drive. I have an 1 terabyte. I think it's in one of the computers. I have almost similar computers in the garage. I have a Samsung something, like a Samsung M2 SSD. No, it's a normal SSD, and this one is. Yeah, it doesn't matter. It's it's either a Kingston or something. It's definitely fast enough. Yeah, do buy a SSD drive. That is definitely the best increase of speed you will ever notice. When I boot my computer, it takes approximately 20 seconds, and that's Windows 10. It goes, the BIOS goes through like 5 or 10 seconds, and then it goes black. All the screens go black in 5 seconds, and then pop, then I have the login screen. And that's a huge increase from just a spinning disk. So this actually looks pretty good. Now the only thing I need to take into account is what the hell am I going to use this the not used space for? I hate this, because when I'm running the CNC machine, it's so easy to just fill out this with some other stuff. So maybe instead of actually milling it out right now, I should try and figure out what else I could make. So let's just double check the simulation. It takes around 1 hour, according to the simulation, to mill out all of this. You can usually add some minutes in there, so you can probably say, well, it's going to take closer to 1 hour and 15 minutes, or yeah. You will do a chair. Well, yes, I could do a chair, but it will not fit in that small space. What I could do is make something for kids, maybe. I don't know. I'll just have to go grab my coffee. I'll be right back. So maybe I could do another Twitch sign. This was actually made of what do you call it? Glued wood. When wood is glued together. I just had some rest material from. I have no idea where I got it from, actually. I usually collect when I find rest pieces of wood that are bigger than 50 by 50 centimeters or something. I'll just go, ooh, I'll put that into a shelf, and then sometime later down the road, when I need to test out something, I just use that. I think actually this is a part of probably an IKEA shelf or something. You know, the ones that modular shelves that use those types of wood. So there's also space in the bottom. It will be a chair for your kids. Well, it's going to be small. So let's take a look at how big that size we have left is, actually. So we can turn on the stock, and we can just go back into model, just make a save of this. And let's just make a square, just to try and get the idea how much stuff we have for here. So we have, like, at the most around 45 centimeters, 45 centimeters times 40 centimeters left of material on that side. That's not enough for a chair. And remember that this is 12 millimeters plywood, so, and let's see if you just go like this for now. 25 times 64 centimeters. That's actually a huge piece of wood. 64 centimeters. So what can we do? What do I need? What do I don't need? What I don't need is more stuff around the house. My house is completely filled with stupid stuff. Maybe I should just give this away. Come and get it, and you'll get it. Maybe. Did a quick dumpster dive and found a bunch of fresh cables for future projects. Awesome. I love that. I have so much cables. I have boxes and boxes and boxes of used cables, audio cables, video cables, Ethernet cables, power adapters, and I use power adapters a lot. You can sell it. Do you need the money? Let's do a quick look on Pinterest. Pinterest is a nice place to gather ideas. We need to put them to use. Yeah, definitely. Unused cables are stupid, so let's use them. So I need an idea for something 60 times 25 centimeters wide, 12 millimeter sheet of plywood I can make something of. Or at least that's one part of that project. Another one was like 40 times something. So I have a pin called CNC that I usually say if I see something that's interesting but not now project, like these lamps. These are cool. So, but to make this out of 12 millimeters of plywood is super overkill, because it's going to be so heavy and it's not going to be good looking at all. So yeah, let's build the backpacks. Let's build stream backpacks. Apparently there's a lot of in real life streamers that need good streaming backpacks. Look at this guy is actually making a chair, I think, but he's using more than that size, definitely. So what other stuff can I make? Help me out here. I really need to use the entire width of the plywood, so I'm not left with more. Stool. Alright. That's probably small enough. So how do you make this one? This looks like it's... Can you type out the measurements? Yeah, I'll do that. Hang on. But it kind of looks like I'm making a stool. So it's 50 centimeters times 40 something ish. Yeah, 50 times 40. So hang on, 50 centimeters times 40 centimeters, and the last one, I actually have another one there, so if we could do a small one, like a thin one, or we could do a bigger one down here. So 57 times 20, or 57 centimeters times 20 centimeters, or can do bigger, so we can go something all the way up here, or somewhere between. But it's 60, almost 68 times 26. 68 centimeters times 26 centimeters. That is perfect for bathroom equipment, right? Yeah, probably. All depends though on what kind of bathroom equipment you want. If you want something that holds a piece of paper, maybe, I don't know. Let's have a look at Pinterest again. This is not taking that much space, is it? I wonder what the dimensions on these types of chairs are. Actually, you can just take that. There's a lot of stuff here I can actually put into use. Wooden doll cradle, but that's not going to work with a 12mm piece of plywood. That's going to be heavy. It might work on the side panels, but the middle ones is not going to. Yeah, it's going to be huge. These are too detailed for a 4mm bit. It will just vanish. So that will work much better on a laser cutter, or a smaller end mill. So what do people make? Just having a look around. I actually went to our local electronics store today and ordered myself another office chair, because this one is horrible to sit in and I've been using it for 10 years and now I'm kind of finished with it. Unfortunately, the new chair will not arrive until the end of December, so I guess I'm stuck with this one a little longer. So what with a bird cage? Still 12mm plywood for a bird cage. That's a huge bird cage. But I guess the birds don't mind. Better insulation for the birds. Actually, I just remember something. I need to make some samples for another customer. Let's just have. Actually, I think I'm just going to do that because I have to do that anyway. And why not do it on this piece of plywood? So I just have to find some numbers on my Excel sheet. So this customer wanted circular plywood, 12mm, in the dimensions of 60 centimeters, 55, 50, 45, 40, 35, and 30. 30 we can probably fit in here. So circle, center diameter, yeah, let's just make it on that one. Sure. Let's just stuff it in there. So 30 centimeters. Yeah, that will fit. But then we will need another 30 centimeters inside that. I will need a frame for that as well. So 15 centimeter. Actually, I think 15 centimeters is better for this. I'm just thinking now. Tropisk. Oh, that didn't turn out good. So 45. How huge is 10 centimeter and 15 centimeters with 5mm hole in the middle. So that is 10 and that is 15. But what is that one? Is that 5 or is that mentioned? So 1, 2, 3, 4, 10 centimeters, and then 1, 15. And then probably interesting. Probably won't fit that anyway, but let's try it. So let's put on these numbers inside the parametric design. So big dim circle 15, and that's 150 millimeters. Circle 10 is the 100 millimeters, and that probably will be circle 5, I guess. Looks like it's 50 millimeters, and we also need a hole dimension in the middle, and that should apparently be 5 millimeters. All right. And we would need 1, 2, 3, 4 of that one. So just to make sure, let's save this and then let's make it. So now I just switched to making a real life project for another customer that I'm actually waiting for an answer from. So circle 15, yeah, that's circle 15, and in the middle of circle 15 we will need a whole dimension, whole dimension. That's definitely not a whole dimension, whole dim. There you go. It's a whole dim, and that should be 5 millimeter. Yeah, correct. So, and now we're going to extrude that with the thickness of our plywood. So we'll just go down there, new body. Actually, we make a component of, no, let's keep it at the body for now. So that's supposed to be the middle one, this one. I guess that's 15. They don't say anything about how big these ones are. I can try to calculate it using, if I import that PDF, or just make a screenshot actually. So copy to clipboard, insert, attach canvas, yeah sure, make it front. And then just save this as a screenshot. Come on then. We don't care about the resolution, we only care about the dimensions. So let's see if we can find those. Let's put them in there. So the thing we do know is that the biggest one is probably 15 centimeters. And then we need to calculate the other ones. So we need to make a 15 centimeters big. I wonder about that. Come on then. Oh, this is really getting annoying now. 15 mil. Come on, 15 centimeters. Awesome. Ragamuffin is back home. Welcome home. We missed you. So 15, so that's a 15. So we need to scale that picture up a lot. So where is our canvas? And we need to calibrate, and we need that side and that side to be 150 millimeters. Oh, close. So close. So we'll just we just need to move. Where's the move? Apparently I'm not able to move my canvas. Why is that? Move, create, edit canvas, replace canvas, but no move. Well, then the mountain has to come to, so we just move our sketch instead. So extrude that into a, so yeah. So what are you asking? Second circle on the left is wrong or not? Right part of this circle is under the blue one. I'm not sure I understood that question, but right part of this circle is under the blue one on the left. Well, yeah, these ones are kind of above each other. Yeah, that's correct, but I think I still need to carve out the... So yeah, I'll just focus on getting this done. 12.25 millimeters. Second circle from the left, the other one, yeah. And that's, yeah, that's in front and the other one's in back, yeah. But they can fix that later, I guess. And that might also be a kind of a design thing. You can also see they're not kind of the same direction, so they might look cool that way. I don't know. So, but let's do this. Body, move, something like that. Yeah. All right. So apparently the other ones should be around 10 centimeters. 10 centimeters. That's not 10 centimeters. 10, 100 come on, man. So these in the drawing are definitely not 10. Interesting. And what about this one? It's closer to 11 or 12. So either my scale is wrong or the drawing is wrong. But, well, the customer is going to get what the customer is asking for. So 10 and 15. Alright. Let's do 10 and 15. So at least these are the same dimensions. And the question is, what is this one? So that's closer to... Oh, it's close to 8. So let's do 8. That's 8. Or 9. Let's do 8. And then the last one here. What do you think that wasn't? It's closer to... that's super close to 6 or 7. 6.5 or something. Alright. So let's do 2 6 centimeters, 2 8 centimeters, 2 10, 4 10, and 1 15. Alright. So let's just put that back into our parametric design. And the reason why I'm using parametric design is because when the customer calls back and say, well, I didn't want 7, I wanted 8, and I can just change it here. So circle, circle 8, that's not what I said, 8, and that's 80 millimeter. And then the next one is circle, what was the last one I said, 6? Yeah, I think so. 6, 60. And then we need something called spacer. They need something in the back that kind of holds this out from the wall, and that's going to be whatever they want. So we'll just use we're going to use up the whatever space we have available. So 40, come on, man. If they're less than 5 centimeters in diameter, then they're gonna get wobbly. So let's we can probably fit this in anywhere on this stock material. So let's do 80 millimeters. So this is called 15 centimeter circle. I think I just pulled a going to get a coal or something. So we have 115 with a 5mm hole in the middle. Cool. Then the next one we need is circle. It's going to be circle 10, right? Why is the mouse taking over when I start typing? It didn't used to be like that. So, and then we need a hole dim in the middle. And then we need an extrude, and we will need the thickness of our material, and we will need make a new body. So, yes, awesome. And then we will need more. So we will need 4 of those 10. Well, let's just keep doing this. Let's do the 8 first. So circle 8. And then hold him in the middle. Have you already had snow in Norway or not? Yes, we had snow yesterday. I drove from Fredrikstad to Oslo, the capital of Norway, yesterday. And it was very interesting because people crashed everywhere. People apparently forget how to drive on snow when it takes a year between. So yeah, the first snow landed yesterday and it was 10 centimeters of snow. And it rained away during the day. So that was an 8 centimeter circle, come on. And then do 6 centimeter circle 6. Where are you? Circle 6, yes, we like that. And we need a hole, hold him. So now we're going to extrude that in the same way on the back side. Yes, we're going to make a new body. Yes. Yesterday it was 20 degrees in Warsaw. That's awesome. Oh, I wish I lived in Poland right now. No clothes at all. Jesus. Yeah, but it's the funny thing is it's today it's actually like closer to 9 degrees outside. You can see that on my surveillance. You can see it's actually raining. There's no snow outside anymore. And yeah. So summer just arrived again, I guess. So 115, we need 4 of the 10 centimeter, and then we need 2 of the 8, and then 2 of the 1. So let's. There's a nice pattern generator inside this, but just we don't need that right now. So 10 centimeter circle, and then we need a 8 centimeter circle. There's goddamn mosquitoes outside here. Well, I think we had a couple of weeks with minus degrees now, and do you have a surveillance monitor up all day? Well, not usually. I usually use that screen for something else. But when I work in the garage, I really like to monitor the environment as well. If some of my neighbors have a problem or something, or if something catches fire or something happens during while I sit inside and the stuff is working outside in the garage, then I really need to monitor the environment as well, and not only just the mill. So it's really nice to just turn on the screen and just check out what's going on. So let's copy this. Copy, paste, yeah, let's move, come on. Let's just do like something like that, or this, I don't know. It really doesn't matter. So 10 centimeters, paste, and then something like that. And then I have to remember to make the spacer as well. So paste, where did my paste go? My paste just disappeared. Alright, interesting. There's the paste. So now I have 1, 2, 3, 4, yeah, I have enough. So yeah, my firewall is up to date, so that's all right. So let's just ten. Let's just move that down so we have all of the 10s at the same place. Yeah, sure, cool, awesome. Move. And then we need 2 8s, wasn't it? 2? That was the wrong window. So these are the 8s. So 1, 2, yeah, sure, 2 of those. Copy, paste. Sure, awesome. Yes, let's do that. Something like that. And then we need 1 more of that 6. Copy, paste. Let's move that somewhere over here, I guess. So this looks better now, doesn't it? And we kind of filled out some of that space. I can probably make another one. It's always nice to make more parts than necessary. If something breaks, or then you don't have to start up the process all over. So let's make at least 1 more of these. Paste. Let's make another one. Paste. And then make another of the 15. Copy, paste. And then we need yeah, at least 1 or 2 more of that 6. Copy, paste. So this is nice, right? Now I'm doing 2 projects at the same piece of plywood. It takes approximately, it takes like 2 minutes longer per circle or something, but it really doesn't matter. It's just gonna continue working until it's finished anyway, or until something breaks. And so if I make 2 more of those, I have no 8 centimeters extra, so if I make 2 more of those, that's 1. And 2 more 10, then I have double of everything. If I'm not mistaken. So let's do 2 more 10s. Well, so let's see, 1, 2, 3, 4, 5, 6, yeah. And let's just sort this in a proper way so it's easy to find them. 1, 2, 3, 4, 5, 6, 7. And where's the last one? 1, 2, 3, 4, 5, 6, 7. Alright, and we need another one. Copy, paste. Yeah, awesome. So, and now we need spacers. So we will need at least 1 spacer per circle if we are going to have that piece of decoration stand out more than nothing from the wall. Then it's going to be 12 millimeters from the wall. So if we stack that double, then we have 24 millimeters from the wall. Then we will need 2 for each. So if there is 1, 2, 3, 4, 5, 6, 7, 8, 9, at least 9. 9, so we should have at least 18 spacers, but let's make more. But we haven't made anyone yet, so let's make them right now. So let's draw a spacer. Circle, centimeter, yeah, sure. Let's do it down here, I guess. Let's do it in here. So circle, and it's called spacer, yes. And its hole is hole dim. And then we're gonna extrude it until the back face of this plate. I'm gonna make a new body. So, and these ones I really need to make a lot of. I need to make at least 18 of these, probably even more. So I'm going to call this spacer. And I'm going to use something else to generate this. I'm going to use a pattern, and I'm going to use a rectangular pattern. I'm going to set this up with the 2 axes. So I'm going to use this object, and I'm going to go in this or this direction, like that. I'm going to leave at least 4 millimeters on each side of that circle, or it will not fit. And then I want to make an additional direction. So where's the one direction? Come on. So directions. Select the other direction, and that's that way. Oh, that didn't go as planned. So we want the direction that's this way. But why can't I make additional direction? What am I missing? So one direction, one direction. I've done this 10,000 times, but I've never seen suppress. So spacing should be 5 millimeter. Oh, I'll just do it manually. And that's the last direction, and that's the same. And 3 by 3 is 9. And if we do, let's see how we can manage this. I really want to make use of all that space over there. So so now we're making 20 of them. But we need to make, so let's use less space in that direction. Oh, hello, all of those spacers. Let's, maybe we can create a group of these and just move the entire group. So let's move them over here. So can even put even more of them around here. We could make another pattern. We can just do this manually. So let's do 3 and 3. So let's do these 3. Copy and paste. And let's just move them manually. I guess this space. So the, oh shit, these spaces really don't have to be. They can't be bigger than the smallest dimension circle, and the smallest dimension circle is 6. So if the spacer is 8, then it's going to stick outside of the smallest circle. So we needed to make it smaller. Luckily, we can fix that easily. So before we do this, let's go back and go to parameters, go into spacers, and that spacer will now never be above 4. It's going to be small, but it's just going to stand there on the wall. It's not going to support anything else than the weight of a tiny piece of plywood. And now we can go in and change the pattern dimension so we can fit more in the same space, I guess. So now we can have more spacers. So let's do so this looks alright, I guess. Well, something didn't turn out good there. Looks like I need to rewind a little bit. Let's undo that one and then go back to that design. Where's that design? So that's the first one, and that's the pattern. Yeah, let's just make the pattern all over then. So let's first just move the spacer where it's supposed to go. Over here, I guess. And then go pattern, rectangular. Yes, awesome. This one. In 2 directions, we want it to go in this direction and this direction. And then we need to decide how much. 50. Oh, we're using the wrong object now. Oh, there we go. And then we increase the amount of spacers. So, let's just turn this down a little bit. That's a lot of spacers. So how many do we actually need? So if we want this to stand out, let's say 5 centimeters from the wall, then we would need 4 spacers per circle. So 4 times 9. I can just do this, I guess. And that will be the proper amount of spacers for 5 centimeters from the wall. And if they want more than that, I would really suggest another way of mounting this, because it's going to get a little bit fragile after that. If you have a bolt that's 5 centimeters plus the first one, 6 centimeters, and then it's going to go further into the wall. Yeah. Good enough, I guess. Oh, the pattern crashed. No. One error. Compute failed. Alright. One or more patterns instead could not be intersected with the original body. Try adjusting the pattern setting or changing the selections. I really think that this could be made another way though. Imagine if we make a back plate on the wall to be able to mount this nicely. So if we take this design and we do something like, yeah, something like this for now. and then we kind of decide where the center holes would be. It would help if this design was, this graphic was actually to scale, but it's not. So if I would make holes for all the bolts going where they're supposed to go. So let's try this. Tangent circle. Oh, hello. Come on, man. Okay, 3-point circle then. And turn off that stupid snap. So let's just go step by step with this. Do, 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 do. It's probably not the best idea to use that 3-point circle because it might fuck up the circular aspect of this. Let's use a 2-point. So close enough. This is the most exciting television ever made. Sitting at home watching a person draw a circle inside a CAD program. Well, if you can sit and watch people play Minecraft, I guess you can sit and watch people do this. At least this is a physical production of a described project, I guess. So we're going from nothing to something hardware in a few hours. So now the interesting starts to happen because I haven't defined whole dim here. So let's do that. Whole dim 5. And it really doesn't matter how big those circles are supposed to be, as long as those whole dimensions and the positions are correct, if you know what I mean. Hold him. No, hold him. Come on. I really need to search why that's happening. So hold him. Yeah, awesome. Hold him. Hold him. Oh, I'm missing one there. So which one is it? Ah, it's that one. Hold him. Hold him. Hold him. Oh, that's not a hold him. That's another cup of tea. So hold. Come on, hold him. Why does that happen? That's with a newer version of this Fusion 360 software, suddenly it just stopped snapping to the text you're writing. And that's stupid. So circle, 2-point circle, and let's do this for the last one. From around here to around. Good enough. Circle, hold him. Yeah, awesome. Alright. So, what we need to do now is to select everything except the holes in the middle. And we need to scale the outside square into something that we actually want to make. It really shouldn't be that much bigger than the structure itself. Unless that's okay. So what's the best solution for this? Let's make it smaller than the holes or the circles. So as long as we keep inside all of these hole dimensions, we're okay. So if we go circular, maybe it don't need to be circular at all. Maybe we just make a line. Let's try something. Let's make another parameter and make that outer dim. Outer hole dim, actually. And that's, let's call that no more than 4 centimeters, because that's our spacers, right? So 40. And let's put all of those outer hole dim. Yeah. Outer hole dim. Yeah. Outer hole dim. Yeah, awesome. Outer hole dim. Outer hole dim. Outer hole dim. Outer hole dim. And guess what? And the last one. And now we only need to make some lines going from the outer faces of that circle to the next one. And then we have the structure that you can hang this on the wall with. Interesting. So how do we make this look good? Control creates a spline driven by the selected control points. Ooh, interesting. So select the first point to start the spline, select additional points as control points. Alright, so I want to start on the outer side of somewhere around here, I guess. Or do I want to start at the uttermost vertical line of that circle? Around here. Let's just try it. We need to work this out anyway. So, and then we need to do the same here. So around here and around here, I guess, and then around here. I wish there was a way to snap to the top side of a circle. But I guess you can't ask for everything. So around here, around there, and hopefully around there. And then we need to go back into the bottom side. Well, no, we have to go to this side first. And then we have to go to around here. And then around there. Really wondering how this will look like in the end. So yes, we're finished. Alright. Guess what? This is the mounting fixture for that thing. It kind of messed up over here. Probably messed up several places. But is that a problem, is the question. As long as it's not more than 6 centimeters out of that one. Oh, we're good, we're good, we're good. Alright. So now the fun starts. So let's stop this sketch, and we need to extrude this. No, probably not that one. Only that one. All of the inner pieces of this one. Oh, I hate it when you do mass selection and you have kind of no, if you click one wrong button, then you messed up and then you have to start all over. Like that. So where's the rest of, oh, there's a body in front of that, that's why. So this I guess you can probably see where I'm going with this. It really doesn't matter how this back plate looks like as long as it's covered by the front plates, right? I guess. Because the front, all the green circles in front of that will cover up all the back ones. And it's probably going to look like something like this. It's going to be covered with different kinds of moss or grass or whatever. I have no idea about that one. That is not my field. But it's probably going to look awesome. So, let's extrude that before I unselect it. It's super easy to fuck up there. 12.25 millimeter. Sure. Now we have our first spacer. That is, we are able to mount this vertically on the wall in the desired angle, whatever that might be. That will have to be up to the customer how they want to mount this. And we can make 2 additional holes for hanging it on the wall, or they can, should we do that maybe? So where do you want to fit this? Probably an end around here. But they will have to decide that. It depends on the wall, the mounting fixtures and everything. If they have a concrete wall, they probably can just hang with the 2 bolts. If they have a well, what is yips called? And probably might need more. I don't know. So let's call this not vlog. So why is okay, then we need to carve out this one as well. So let's just copy that piece. I'll just rename it back plate. Let's copy that over to our other project. Where's that paste button when I need it? So we need to be in that project, and we need to select bodies, and we need to go paste. Come on then. Paste. Or are we not able to do that? Apparently. Copy. And no paste. Alright. Well then just be that way. Maybe if I make a component first. Sure, let's do that. And then we copy and then we paste. Paste new. Alright. So I was able to paste in a component but not a body from another project. That's nice to know. So we just need this to be around here somewhere. Yeah, it's good enough. Capture position, yeah, sure. So I'll be back in 2 minutes. I just need to go to the bathroom. So, back again. It's nice to reuse all of that old music I made 10 years ago. It's nice to have a break to go to the bathroom, have a cup of coffee, and grab something to eat. I also think it's nice to get then like an audio break from a monotone dialogue for that's been going on for a few hours, or at least 1 hour. Oh, 2.5 hours actually. All right. So this is starting to look like something. I've been making a spacer that holds that all of that front stuff. Good. And then my 4cm spacer goes above that one again. Actually, it might be able better to just mill out more of these holders. Then it doesn't look like that weird from behind. Alright, I'll just do that. Skip the spacers. Bye bye spacer. So, and then just do more of those. Copy, backplate, paste. And then let's just put that one somewhere else where we can fit it. And actually we need 2 more because we are making 1 set extra. So copy, paste. Like that. And then 1 more. Copy, paste. Suddenly we almost used up the entire space of the workspace. So let's just move these 1, 2, and 3. Let's move those back a little bit. Maybe into here. 2 of them can actually fit in there, so the last one is, then we get a bigger space there. Yeah, let's just work a little bit with that. Ooh. Let's go back and use that space there. And then if you flip those two to be curved the other direction, then they will use less space actually. Something like that. No, it's a little bit too close. We can fix that, I guess. Something like that. And then this one needs to get a little bit closer to the other one. Yeah. All right. So let's try that. So if you just joined, today we're making this bookshelf, 2 meter times 1.5 meters diameter circular bookshelf. I kind of already tried that in a smaller scale. First a big scale. Never go big scale first. Mythbusters always say that. Always go small scale first, and I didn't. So I tried making like a 1 meter circular thing bookshelf. I messed that up because of my plywood dimensions were not properly set up. So then I went back 1 step and made a smaller one, this one, and I fixed the dimensions, and that fits perfectly. So then I went back and made a new one with the new dimensions in the big scale, this one. And now I'm just working on trying to get as many of those pieces into one piece of plywood as possible. So that's what I end up with this. And I'm only missing one piece, and that's this one. So I need to carve out this one later on. But for now, let's just skip that and do all the other ones. And actually manage to fit in another project here as well. Hopefully that will be nice. I still have more space left, so I will probably actually just do those spacers anyway, just to be just in case. You never know. Suddenly the customer wants those anyway, so it's much better to use up the space now than later, because I'm not able to go back and mill out these kind of corners and all of that after I've been destructing this piece of plywood. So that one, paste. Oh. And we need at least 9 of those. And now we have 2, 4, 5. So we need 6, 7, 8, yeah, so this is how this bookshelf is going to look like when it's finished, approximately. Yeah. 1, 2, 3, 4, 5, 6, 7, 8, 9. Make a winter sled for your kids is a good suggestion. Well, that's not a bad idea actually. 2, 4, 6, 8. Need one more. So now I need to leave the stream because my kids are home from the kindergarten. I'll be back later tonight, probably at 8:30, and do the carve out on the CNC. So if you want to see that, just join me then. And thanks for watching. All right, see you later. Bye bye.